All right, so systems of equations. So if we are doing systems of equations, this is technically a topic that you have covered in Math 1, but it's sometimes that topic that either teachers don't get to or you only spend a little bit of time on it. So we always cover it again in Math 2. It is still a part of our standards. And today we are just covering substitution. All right, so substitution is a method for solving systems of equations by substituting equations within each other. So the very first thing we're going to do is solve for x or y. Now, I really want you to understand that it does not matter which one you solve for, but there will be an easier way. Okay, so I'll show you a little later on. We might solve for y for most of this worksheet, but then solving for x might be so much easier for another problem. So we're going to do that, whichever one works, x or y. So we will substitute this expression into the other equation. After we solve for x or y, we substitute that into the other equation and solve for the other variable. And then we substitute that answer from step 1 and solve for the next variable. Now that right there in words makes no sense. You're going to see what I'm talking about here in just a second. So for number 1, we have y equals 6x. So they already did the first step right there. Solve one equation for x or y. That 6x, we solve that for y. Okay? So if y equals 6x, you see that we have a y right here as well. So what we can do is we can plug that 6x in to that y, which is exactly what we're going to do. So 2x plus 3 times 6x equals negative 20. So in other words, if y is equal to 6x, then I can plug it in wherever I see a y. It's the same thing. And now if you notice, when you multiply this out, you only have x's on this side, right? So that will give me 20x equals negative 20, and when we divide that, x equals negative 1. So we have x equals negative 1, and we will take that negative 1 and plug it back into our original equation. Right? So if we plug in a negative 1 right there, it's already solved for y. So if x equals negative 1 and y equals 6x, we're just going to take that negative 1 and plug it back in here. So 6 times negative 1 and y equals negative 6. Now, the whole point of this is I'm giving you two different lines, right? So this could be y equals 6x, and this could be the 2x plus 3y equals negative 20. I'm giving you two different lines, and I'm asking, hey, where do they cross? What is the solution of these two lines? We talked about solutions with quadratics and how it's where it crosses the x-axis. Well, solutions of a system of equations or multiple equations is just where these two equations cross. So in other words, we're asking for a point. All of your answers will be a point, or it'll be no solution if they don't cross. So our x equals negative 1 and y equals negative 6 is going to be our final answer here. Negative 1, negative 6. There is our solution. For number 3, so you see for number 3, it's a little different. They have already solved for x instead of for y. So we're going to take this 4y plus 7 and plug it in wherever we see an x. And I'm going to copy down that line exactly how it usually is, except instead of writing x, I'm going to put the 4y plus 7. So I take that 2 and distribute it. That will give me 8y plus 14 minus 6y equals 12. That will give me 2y, and I'll go ahead and subtract that 14 over. That'll be a negative 2, and y will equal a negative 1. So we got y equals negative 1. Now we need to solve for x. So I take that y and plug it back into my x equation. So that negative 1 right there is going to go into this y. So that'll be x equals 4 times negative 1 plus 7, and that will be a positive 3. Now be careful, because we solve for y first, but that doesn't mean we put it first in the coordinates. We always have x first in our coordinates, 3, and then our y is a negative 1. And that was for number 3, not number 2, but yeah, you get what I'm saying. All right, so for number 4, this is the first one we see where they didn't automatically solve one of the two variables for us. Now, it will be easiest to solve for this y that has a 1 in front of it because you're not going to have to divide by anything. To solve for y here, we just need to subtract 2x to both sides. So that'll be negative 2x plus 9. So the two equations that I'm using now are this top one and the one that we just changed. So I'm not even worrying about this anymore. You don't have to mark it off like that if you don't want to, but just understand that these are the two equations that you're using now. So I'm going to take this negative 2x plus 9 and plug it in for y up here. Okay, so we have 2x minus 3 in parentheses negative 2x plus 9 equals negative 11. We're going to have to distribute that negative 3. We keep the 2x. That will be plus 6x and minus 27 equals negative 11. 8x, I'm going to add 27 to negative 11. That'll give me a positive 16, and x will equal 2. So I take that 2. So I got my x. Now I'm looking for y, and I can just use this equation that we already have for y, negative 2x plus 9, negative 2x plus 9, and take that and plug it back in. Plug in the x. So negative 2 times 2 plus 9, that will be negative 4 plus 9, which will give me 5. So my final answer here is 2, 5. That point is your answer for number 4. So let me look at these and see which ones you might struggle with. Number 5, the thing you should solve for is y right there. For number 6, notice here for number 6 that the term that has a coefficient of 1 is the x, not the y. So what we're going to do here is we will solve for x here, and that will be negative 5y plus 4, and I'm going to use that one instead of the other. Negative 5y plus 4. I'm going to substitute that in for the x. So we will have 3 times negative 5y plus 4 plus 15y equals negative 1. That'll be a negative 15y plus 12 plus 15y equals negative 1. So now you see that these cancel out. That negative 15 and the positive 15y cancel out, and you're left with 12 equals negative 1. Now, if you see that the 12 equals negative 1, and you see that all the variables have canceled out, if that's a true statement, our answer is going to be infinitely many solutions. In other words, they're actually the same line. So in other words, if I'm asking where do these two lines cross, it's the same line. So they cross an infinite amount of times. That would be if they were the same thing. Here we do not have that. It is different. These are not the same thing. So that is not true. So really what we have here are parallel lines, two lines that never intersect at all. So our answer for the solution for where these cross is no solution. It doesn't intersect. So for number 6, our answer is no solution. I'll do a couple more with you. Let's see here. I'll do 10 and 11 with you. So for number 10, you see that the thing that we should solve for is y, because it has a coefficient of 1. So that will be y equals negative 2x plus 18. We're going to take that negative 2x plus 18 and plug it in for y here. So that will be 6x plus 3 times negative 2x plus 18 equals 54, and this will be another one of those special cases. So 6x minus 6x plus 54 equals 54. So here is one of the cases where those variables canceled out, and we have 54 equals 54. That is a true statement, yes. So that means our answer is infinitely many. Those are the same line, which if you look at this, and divide each of them by 3, you're going to get the same answer. You're going to get the same line. Excuse me. So for number 11, this one I chose just because people always get tricked up on this. They're like, wait a minute, which one do we solve for? It's already solved for you, right? So you still do the same thing. The 4x minus 1, you plug it in where you see a y. This actually is one of the easiest problems. It just looks difficult and freaks people out. So now we just have the variables on either side of the equation, and we would subtract the 2x and add the 1. X will equal negative 2. And then from there, we just take that and plug it back into the y. So y equals 4x minus 1, and we'll plug in a negative 2 there. So that will be a negative 9, and my final answer is negative 2